All right, so everyone can see my code going on here. Cool. It says Intro to Object-Oriented Programming. Give me a thumbs up if you can see it. Awesome. Cool. Thank you, guys. All right. So last time we talked about was basically the first part of not even all of section 6. We actually did like maybe 2/3 of section 6. And so we're actually going to kind of continue that on, finish section 6, and then we're going to talk about parts of section 7. I'm not going to go through every aspect of section 7, but so it's important that you guys do read that section. But again, if you guys want a refresher at some point, I do have the link here for the video for last time. I think everyone was there, so hopefully you guys remember. But if you want to ever review it again, you can check that out. And then I'm going to send you guys all through the chat, or not. I'm going to send you the link to this collab book. And note that, I'm just putting it on the Slack. So that's the collab part. Note that that means anyone can go ahead and start editing this. Eventually I'll lock it so that way not everyone's editing it. So don't accidentally, I mean, try not to delete anything. You know, I do have an extra copy and stuff like that, but if you delete it, that means other people can't see. But this is Google Colab. We talked about using this before. It's like a Jupyter Notebook clone equivalent, but we can use our notebooks, and it allows you to interact with it too. So kind of quickly go through, we talked about what is object-oriented programming. If you guys remember, I used like the analogy of a blueprint or a mold, right? Kind of like pouring, I think of it like pouring in plastic into a mold. And does anyone remember what we mean when we use the mold to make a new object? There's a word we use for that. It starts with the letter I.
Instantiation.
Instantiation, very good. Okay, so instantiation, we create an instance of that class, right? That class, our mold, creates an object, we instantiate an object, okay? So we talked a little bit about, you know, all these different classes and stuff, or like why we use object-oriented programming. We talked about the class. I kept using the format of a robot, all right? And we basically got it more and more complicated every time, just going all the way through it, right? So hopefully this all sounds pretty familiar. I think you guys said it felt pretty straightforward, nothing too complicated. And then we talked about how we can basically put in variables within our class. So for example, on this class robot right here, we created different variables for the robot itself. So that way the robot actually has, what's it called? Like attributes. So it has a name, it has material, it has its electric number of arms. So that way every class we make will have those attributes and stuff like that. And then this is about where we stopped right here with our methods, our functions. So I mentioned that methods are functions, and methods are really, they're bound to either a class or to an object. And you can kind of think of it like, you know, things that you would do. You know, for example, if you have the person class, a method might be breathing, you know, like the person can breathe, or the person can throw, or the person can eat, or the person can, you know, do all these other attributes, right? These are different methods. Really, methods are functions, and sometimes, to be honest, I'll mix the two together, say function instead of saying method. But just know that they're pretty much the same. It's just that method is tied to an object specifically. Okay, cool. All right, and so if you guys seen section 6, this sounds pretty familiar. We have something called class methods, and those basically are the methods that belong to the class, the mold itself. So in our example here, we have our little robot, and I gave it a little class, variable here, law of robotics. So first law, second law, third law, and you'll see it's just a list, right? So I can put whatever variable I want. I predefined what this variable is instead of leaving it blank, okay? And then I also defined, you know, this function called print laws. So you can see, for example, we have for law in robot.laws of robotics. So you'll notice here it's a little different from our normal. We'll talk about what this is exactly. Note that it doesn't take any inputs. It's completely blank, right? And then I also have print n law, which is I take in the, some number, some integer, and basically print out either 1, 2, or 3. And I do a little quick check right here to say, oh, is it actually 1, 2, or 3? If it's not, if it's less than 1 or greater than 3, I'm not gonna print out that law, right? Otherwise, I'll print out that law. Cool, simple enough, right? Hopefully nothing too complicated on there. So again, I make my class here, and I can actually use now, now notice, did I ever make an object with the robot? Did I ever instantiate it or make an instance? No, right? But I can still get the law of robotics from robots. So this is like the mold. It's kind of like this variable is tied directly. It's bound to the mold called robots, the class robots. And you can see I do that robots, and I can actually get this, a variable, this list, right? And you can see I also call the function, print laws, right? And I can also print, the second law. You can see I do that specifically. Cool, all right. So we haven't seen this directly. You might have seen it referenced a couple of times, depending on how we did things. You might have seen in the curriculum, but these are class methods. Now, when we say a class method, what that really means, it's bound to the class. It's not bound to the object, it's actually bound to the class itself. So when I instantiate an object, Wally, right? And remember, in this case, Wally doesn't actually have any attributes by itself, except for the law of robotics. So I instantiated him. I now have Wally.law of robotics, and that's just basically the variable. I'm not printing it out, I'm just getting that variable itself, right? Law of robotics. And then we can try to go ahead and try to say, okay, Wally.print laws of robotics. And does anyone have a guess what will happen when I run this? Take a wild guess.
It'll print the same laws.
All right, so let's try it. Print same laws. And you would think it is, but you'll notice you get this error, you're like this type error. And it says print laws, right, takes 0 positional arguments, which makes sense. We didn't give any arguments, right, when we defined the function. But it says 1 was given. But it says 1 was given, but we didn't put something in there. Does anyone have a guess what the 1 given actually is? A little tricky. Any guesses? Good, Griffin. I think you want to say something.
The object itself, maybe.
Object itself. Good. That's exactly it. It turns out the argument given is in fact Wally. That is the argument that's given on, and it comes down to this dot. When we do this dot for an object, it basically in a lot of ways we're passing through the function and argument. We're actually passing the object itself, which actually comes down to something called self. So it turns out we can't actually access the class method like this because it's not an object method. It's actually for the class, and that's why this fails. So that's usually not what we want. So we're going to try to play around with our self. So we can actually use this self part right here. And you'll notice when I wrote the function on print laws, there's no argument self. It's just by itself. Versus right here, when I define this class, I'll actually define speak self. And that means that it's basically bound to this object. Is that saying, hey, give me an object, and it'll take that object's and use that attribute.name here. And same thing for add numbers. It needs the object, a number, and then another number, and then it'll do that total here. But the key part is that this needs to be tied to an object. It needs to be bound to an object here. Okay, so let's go ahead and run this part. And you can see when I do Wally equals robot, okay, and also do basically, I'll print out this part. You guys have seen these 3 lines right here. So I'm actually going to print out this whole thing where it's name, and then get Wally's.name, Wally's.material, Wally.electric, Wally.arm. We've seen this before. So that should print out just the attributes right here, since I didn't give it any, I haven't changed Wally at all from the class. But when I do Wally.speak, notice that I have that dot, but I don't give it any arguments, even though it's speak self. You guys see that? So self is a special term that basically it's implicit, saying, oh, Wally is that Wally.speak. So I'm actually gonna comment this out so you can see this first. So I instantiated him, right? You can see all those parts. But then when I do Wally.speak, you can actually see he's gonna print out I am none, which of course his name is none right now because I didn't do anything with his name. And we also can do our Wally.add numbers, right? So you see that I didn't give self, I gave it just a number and a number. And that's because Wally is the self. Does that make sense? Okay, and this makes it really powerful for us to reference the object without having to every time say, pass in Wally, pass in that. We can basically say, oh, I want this guy. I want whatever is over here, whatever object this is, use that for self. And so we can get that self.name, okay? And you can see, for example, if I change his name now and I do speak, we actually will get his I am Wally, since his name now is Wally, right? This is a little more advanced, so don't feel like if this feels a little strange. Basically right here, I'm showing that you can actually change this function. So if I actually go ahead and, oops, if I comment this part out and I just want to see what this function is, it's just a function. You'll see it's a bound method, meaning it's bound to the object, and it's bound to this robot. It turns out this guy right here represents the robot. Okay, so that's what this is saying. But I can actually change that function right here. Remember, lambda is just giving a function. In this case, it's taking no inputs, and it's going to print out Wally, right? So then if I change that, and now change the method, and I'll show you what that looks like. You'll see that now it's a function. It's no longer a bound method, and I can actually call it with Wally.speak and give something different versus what was up here before. Okay, so again, this is a little more advanced, but just know that essentially I'm keeping this .speak. That is a bound method at first, and I just changed it to a function. Okay, cool. Any questions on this guy? All right. So self is one of the more important parts. You'll basically use it. Think of yourself as, when you use self, you're tying that method or whatever you're referencing to that object. So now the object can reference itself. Okay, that's what we call it, self. In other languages, if anyone's familiar with other languages, sometimes this will be called this, T-H-I-S, then Python itself. All right, cool. There's a lot more you can talk about with self in the curriculum. Right here, you can actually look at self and see a little more advanced stuff, and it goes into full detail. It goes into a lot of detail of what you can do, but I was just introducing you to how you do that part. All right, cool. So next part is that we're going to make things private, getters, setters, and deleters. So when we make things private, well, let me ask you guys, why would we want to make variables? Like, I really am talking about is making variables private. So why would we want to make an object's variable private? Any ideas?
We don't want users to change them easily.
Yeah, you don't want a user to accidentally change something, right? Or purposely change something sometimes. Is there any other reasons why you might want to make things private where for a variable, for an object?
Later by variable, are you talking about methods?
It could be a method, but also could be like, for example, when I have this variable here, this name equals none, I can access it, right? I can do, let's do a new code down here. If I do wally.name, right, I can have access to it. If this was run right here, I would never, like, I could do it. I can basically change the name, I can set the name and stuff like that. That's what I mean by private. So I'm just kind of going as a, what's it called, a general idea saying, oh, why would we want things to be private? But I think what Bonnie said is a pretty good reason. There might be other reasons you might think about as we go through this, but we can actually, excuse me, the main reason why we want to make things private is that we don't want users to mostly accidentally change things. Or even when I say users, that could be another data scientist, another programmer. We don't want them to accidentally change things that they didn't mean to. So a big reason why we can make it private is that. Now, for the record, there aren't actually private variables in Python. So every variable that is in Python for an object can be accessed by you. There's not, like for Java, for example, there are explicitly saying, oh, you have private methods, private variables, all that stuff. And Python doesn't exist. But we call something a private variable, or basically private within a class, with an underscore. So you'll usually see this underscore, like start with an underscore and then the variable name or something along those lines. It could be a class method. We'll talk about some built-in methods that are for Python that start with this underscore. Okay, so whenever you see an underscore.
To clarify.
Yeah, go ahead.
Just to clarify, those you can still access, but the underscore is just a notation for the other users that, like, please don't change this.
Yeah.
Is that correct?
That's right.
Okay.
There isn't a way to keep things private in Python. Everything is in its nature public. Means that if someone has the code for it, they can access those variables. The real reason why we do this, to keep things in quote unquote private, is so you don't accidentally change things around. You could, if you really wanted to, you could try to find, what those underscores are, but for the most part, it's kind of like it's convention, really, what it comes down to. Okay, cool. So I'm going to kind of show you guys, since, you know, this seems kind of like, okay, you're talking about this private stuff. What exactly does it mean? And it comes down to this thing using setters and getters. And so the idea here is, before, you'll notice that when I wanted to change the name, I had to do .name if I wanted to get the name, but I also can use .name to equal this part. But let's say I want certain conditions for that name. Let's say I want the name to always start with a capital letter, or I want to say, oh, I don't want a name to be an integer. So for example, if I put in right here, if I put the number 1, that's going to work. Okay, I can set that name. So for example, if I do Wally.name now, you can see that it's just the number 1. But maybe there's some instances like, well, I don't want it to be an integer. I want to make sure there's this extra part. Well, if we define it like this in our class, where name is just an accessible variable, and later on we'll see we'll just do underscore like that, it can be changed, you know, to whatever we want, and we don't have really control. So the idea for a getter and a setter is to basically allow a little more control on what happens when we assign, you know, assign those variables, we make changes to the object itself. So let's see what that looks like. So this right here, I have my class, and you can see that underscore name, and we'll see, I can reference, you know, later on, I can actually reference that name. It's not like actually private, but I put a default of none, right? And we have a function called set the name. So then in the set name, I take the object itself. In this case, it's going to be, you know, Wally. Okay. We're going to set him a new name, and we're changing that variable underscore name to whatever the new name is going to be. So if I change his name to Joe, his name's going to be Joe. If I change his name to, you know, Sharon, I can change it to Sharon. Okay. Then I have this other function called a get, and we're going to get the name. And all we need to get the name is just the object itself, right? We don't need to pass any extra parameters. We just need to get the name from it. So you can see it's this part and this self.name. Note that we didn't have to do just return self.name. We could have done other things to this. We could have like made a title case, or we could have done whatever we wanted before actually getting it. This is what I'm talking about, where you have a little more control of what that get part is. And for completeness, we also have a deleter. We delete the name. So this deletes the name from the object. So if we set it to something, it'll completely erase that information. Okay, cool. Any questions on that? All right. So
the naming, can you hear me?
Mm-hmm, you're fine.
So that's like a must. If you want to write a setter, you just use set underscore plus that function name.
I mean, honestly, I could have named this whatever. I could have named it like, let's say, setter. I could have named it like flip-flop. I could have done whatever name. It's just a name of the function. I named it that just to kind of give you guys an idea of what this function's doing. Does that make sense? So like, I'll show you. So let's say I name this my setting function like that. I don't know. Flippity. Okay. Just because I'm feeling fun. Okay. So this is just basically saying this setting, this setting function is just a name for it. So I'm just basically, it's kind of like more of a concept. It's not like it's an, oh, like it needs to be specifically this name of something to set something. It's just like, oh, this is just the name of the function. Okay. So maybe it makes more sense when I run this out. So if I do this now, the setting function is called my setting func flippity. Okay. But my get function is get name, and delete is delete name. So now if I create an instance of Wally robot, I can set his name. Okay. But in this case, this is not going to work anymore. Wally.mySettingFunction flippity. And what this will do, it'll take the input, which is a name, and it will say, okay, I'm going to take the object, which is from self. I'm going to take the new name, which is Wally, and it's going to say, all right, the object's underscore name will now be Wally. Okay, so if I run this now, you'll see it goes through. So for example, if I check this out, say, okay, what's Wally dot underscore name? Remember, we can always reference the variable. We can see it's Wally. Okay, does that make sense? Okay, so basically I'm just making a function that can set it. So I don't have to say, basically I'm trying to avoid doing this. I'm trying to avoid doing Wally dot underscore name equals Wally. Yeah. So I'm trying to avoid doing that. That's really what this setting function is doing. Okay. And so in a similar way, this Wally.getName, I could have done Wally._name, but now I have this nice function that the user doesn't have to know there's a variable underscore name. They just have to say, oh, use the function .getName, and it works fine. Okay. And then for delete name, basically it'll remove the reference to underscore name. So you can see if I try to get the name now, it gives me none. In fact, if I try to run this now, it'll also say none. It deleted the name. Okay. Or you can see it didn't.
So the user, sorry.
Okay.
You delete the name variable, or you only delete the value, delete the value.
That's right. I'm deleting I'm not deleting the variable, I'm deleting the reference to the variable. So whatever was stored in that variable, I'm deleting that out.
Okay.
Okay. And so you might imagine, for example, a more complicated, the reason why we do this is because it's more complicated. So imagine instead of just giving a name, this is like, you'll probably look at me and say like, why are we doing all this? It seems a lot more complicated than just setting up name or underscore name, right? And you should kind of ask them, that's kind of dumb, right, Victor? Like, why are you giving this more work? And the reason why is because imagine now we have something like a first name and last name. So, and we have something like, oh, I don't want the first name, last name, I just want the name. And so we can actually call a function that says, oh, get name, but the underscore name variable might not exist. Maybe it's just last name and first name. That's all the variables that are in the class, right? But we can still define the things like, oh, we're going to get the name and we're going to assign the name. And when we assign the name, instead of maybe saving it to a variable called name, we might save it to last name, first name, based on some kind of like, maybe split it by some spaces or whatever we want to do to define what a first and last name is. So this is where we can kind of make things a little more abstract. And that's really the goal of object-oriented programming, is how can we make this stuff as abstract as possible? And because when you make it abstract, meaning that, it's not spelled out for you, you can have a lot more power. It's a lot more flexible. It's a lot more things you can do with it by making it abstract. Okay. So it's much more like a philosophy than necessarily saying it's a necessary function or a necessary thing that you need to do. Okay. Yeah, but these are good questions. And yeah, again, if you have something, always stop me like that. That's perfect. Okay. So you can see we have setters, getters, and a deleter, right? But we have to define these names directly. And you saw that the name doesn't actually matter. It's just the idea of what a setter does. A setter sets some variable. A getter gets some variable. And a deleter can delete some variable, okay? So we can actually use something called property. And in the curriculum, it uses this property method, which is built into Python. So you can kind of see real quick, this is just kind of showing you what what's it called? The doc string, basically the help. And you could also have done in Jupyter Notebook property like this. That would have done something similar. But I'm old school, so I always use help like this. But basically it's saying, okay, property is a function. And basically it can take in up to four parameters. Fget, which is going to stand for function for the getter, function for the setter, function for the deleter, and then something called a doc, which is like its doc string, give information. So again, it's probably best just to kind of show you what this looks like. So I kind of made a little more complicated robot right here. And you can see I have default names, last names, and first names. So now I'm going to basically do something. We're going to do the same thing like get the name. So we're going to get the name by just saying, hey, object, tell me return your name. And that's what the self.name is here, right? And then for set, you'll notice that we're doing a little more complicated stuff. And so for set name, I take the object, I'm going to give it a new name. So that's what we're setting the name to. So it's like, okay, we'll go ahead and give whatever new name it gave. We're going to assign it to underscore name. Okay. And we say, okay, new name, we're going to do some extra stuff. We're going to make it title case, which means that if there's multiple words, we just make sure the first letter of each word will be capital. Okay. So that's why we're doing this part. We're doing some extra processes. Okay. If we did just underscore names equal to something like in the code, you couldn't do this. You'd have to tell the user, hey, go ahead and capitalize everything and then save it. But we're doing that for the user, or I should say the user, but the end programmer, which could be ourselves. And then same thing for here, we have our names. So this is right here, I'm actually going to get the first and last name from this name being passed in. So this is some extra processing, for example, of saying how you can say, okay, I'm going to set the name to something and then also get these variables, last name and first name, for our object. So in this right here, this is a little stuff from more Python. I take the name and I'm going to split it by spaces. So it's going to be a list now of saying, okay, like, you know, my first name string, comma, last name string, all within a list. And that first name here, I'm assigning that first name to the very first name that was in that split. And then if there's more than one name, I can go ahead and get the last name. So the idea here is like, oh, if they're only giving me one name, I'm not going to look for a last name because it doesn't exist. So this allows me to kind of do some extra parts. And the important part is not so much what's going on here. It's just the fact that I can do something. When I set the name, I can now do a whole bunch of extra processing. Okay. And then of course I have delete name, which honestly doesn't look that fancy. I could have also done delete self dot, I could have also done this, delete self dot underscore last name, and then also the same thing with first name. And I could have done that because then that way, if you delete a name, you also delete their last and first name, which would make logical sense, right? You're like, oh, that would make sense. So these are things that basically no one's going to see. No one's going to see that there's a bunch of extra stuff happening in the background. And so what happens here, this is what the curriculum does, is you can say, all right, I'm going to have this property called name, okay? And we're going to set it to this function here. And basically we're getting the getter function, which is get name. I just named it up there. Again, we could have named it whatever we want. It could have been flippity flop. The setter, which is set name, and then deleter, delete name. I could have kept some of these off. For example, I could have just done fget or just fset or do both of them, but not the deleter. Just know that that's why I'm setting these explicitly, just so you can see that better. But you don't have to put these explicitly. You can just put them in the right order. Okay. So now let's go and check how when you run it. Okay. And okay, this is the stuff going through. So this right here is this top part is where the curriculum does. That's how it writes everything with this property. To be honest, though, I don't usually see this used as often. I usually see something called decorators, which I added this part right here, and I'll use this more commonly. Is the decorators basically do the same exact thing that this property function does, but it's explicitly tied to the function. So it's a little more complicated, but it's more common. So it's basically the same exact code, but instead of having this name equals property stuff right here, instead there's something special with this @ sign. So I put an @ sign at property, and then the name, and sorry, the function for that name, for that property. So in this case, this is the getter. So the getter is going to be called name, just like how it's name up here. And so you can kind of see the similarity. I would suggest, to be honest, go through this a little bit, maybe like when you have some time to kind of check this out, see how it's similar. Because this is what I see most common. So you'll see most people's code do something like this. But basically this property, this is going to set it to be the getter. To set the setter, we do @name, which is from here, .setter. And then same thing, similar with the deleter here, okay? And basically, you can go into these documents right here that kind of explain a little bit what a decorator is doing, but essentially it's wrapping around functions just like this is doing. It's basically creating this, but tying it, just making it a little bit more like, okay, this is the property for the getter, this is for the setter, this is for the deleter. So it's more closely tied to the actual function versus you might have a whole bunch of things going on here and then later on set this property. This can make it harder to debug when you're trying to figure out what's going on. These are little nuances that you'll see what works well for you as you get into programming, okay? But just know that these will work essentially exactly the same. There's a different way of implementing the same exact thing, okay? Cool. And I know this is kind of, I'm going through it pretty quickly. I know it's kind of like a lot, what's it called? Like a lot to kind of take in. So I'd say really go back to this if you want to try out this method. But this is what you'll probably see most often with programmers, especially if you get something from a CS code or something like that. Okay, so I'm going to show you guys. Well, I should stop for a second. do you guys have any questions on this? I know I haven't really shown you directly what's going on here, but any questions? Okay. Yeah, go ahead, Bonnie.
So each setter is just another function that using the private variable you have, then basically you can have like many setters, right? Under one class.
Yeah, you can have many setters for different variables. Usually there's only one setter. You set the variable with this one part. I guess technically there's not a reason why you couldn't have different ways to set the variable, but we usually think of the setter as saying only taking in one value, which is a like in this case, whatever you're setting it to, and then you're changing that variable. Does that make sense? But in essence, you know, again, a setter is much more like a philosophy versus like saying this is a specific setter function. So I think it might make more sense if I show you guys a little bit of how this would work. So if I have this class here, and I say Wally is equal to robot, right? We know that Wally's name, for example, if I do now Wally dot underscore name, there'll be none because there's nothing in there, right? We don't see anything. Now, normally we'd have to do Wally dot name, and then we have to set it to whatever we want, right? And if we tried this now, right? If we try printing out this dot name, you'll see, well, we didn't get that capital letter, and that's not really what we want. So the idea here is we made this property either from the code up here or using this decorator, this at property, that name, I can actually say, okay, dot name, not underscore name, I can set it equal to this, okay? So now if I do, after I assign it, I do Wally dot name, or actually, I'll just do underscore name since you guys seen that. So note that I gave it this part for dot name, and I'm gonna say, what is that variable actually stored as? And you'll see it's a capital letter. See that? So I did some extra pre-processing. In fact, if I do something like first name, you'll actually see that I get that first name here. And of course, its last name. What would its last name be? Would it have a last name? It wouldn't have a last name, right? So none. If I did something like this, though, you'd see that it does have a last name. Okay. Oh, I didn't put that part in there, so sorry. That part, that's a little bug. But the idea here is that we would have this name, and then if I wanted to call just its name, I can actually use this guy right here, Wally.name, because I'm using the getter now to get the name at that dot name. Okay. Does that make sense to everyone? Okay. And I would strongly suggest going through the curriculum. They do have a lot of examples of this. And of course, what's nice about the curriculum, you guys can go at your own speed too, go back to it. Of course, we only have a limited amount of time, questions like this, but at least you can kind of see how this would work out in the code right here. Okay, cool. Thumbs up, how you feeling? Sideways, like, I don't understand anything. Maybe he's like, I don't know. And he's like, okay, I gotta get it, maybe some practice. Okay, see Olivia kind of going, yeah, okay. All right, cool. So again, really useful to help organize your code. And you'll see me use these decorators just because that's really common. So that's why I threw them in there. But know that the curriculum uses this method right here, this property. Okay, so this goes into, let me see where we're at, about 10 minutes in. Okay, so I'm gonna show you one part and then we're gonna, again, you guys have access to this full Colab notebook. So feel free to, like, copy it, download it. Be aware that, if you make changes to it, other people will make changes. So a good idea, you can go to File, download.ipnb, and then try it in Jupyter Notebook. That's a good way to do it too. But now you'll have access to this since I sent out on Slack this link. But we can basically do something called init, right? Which is basically a way to set up those default values. So right here, we have this special function, and you'll notice that there's underscore init underscore. And whenever you see a function written like this in Python, this is a special function built in for Python. It's you'll see, like, underscore init, underscore underscore. There's also underscore underscore str underscore underscore, which I show later in this notebook. There's a bunch of functions that are specifically built into Python, and that's what this represents. It's a basically it's a private class, but it's also a special one for Python, and Python will use these internally for stuff. So what this does is basically it creates a default for that object. So when I make a new object, when I do Wally equals robot, it'll initialize it with that object, right? And then it'll initialize with its first name, if I give it a first name, and a last name. And you can see I do some extra processing here. Again, it doesn't really matter specifically what I'm doing here, like what it is. It's more like that I can do this stuff. That's what I'm kind of showing you. But you can see I set the attributes directly right here from the start. I set the first name, I can set the last name, the first name, last name, last name. And of course, I also set the name since I already have the name. I initialize it with this underscore name by using this, which is basically, it's joining the first name and last name. Again, go through this because this might be useful for knowing Python, but it doesn't really matter what I'm doing here. It's just more the fact that I can do this, okay? And then you can see we have properties for a setter and getter for last name, a setter and getter for first name, and a setter and getter and a deleter for name, okay? So that's how you can kind of break these up into different parts, okay? And so when I run this now, I can create a robot, and I do robot, but this time it has setters and getters and names for, or setters and getters for name, last name, and first name, and it sets it up with generic and then no last name. So if I run this part, you'll actually see it was generic. I gave this part Wally, just giving it just a last name. I think just a first name is probably misspelled. I'm giving it just a first name. You'll print it out there with no last name. And then you'll see I give a robot here, Bender Rodriguez. And you'll notice I put a little lowercase here just to show you that the setter wasn't used. So I run this now. You'll see I get generic with no last name, just a first name. Wally, no last name, first name, but I define that Wally. And then Bender Rodriguez, you see there's a last name and a first name. Okay, cool. So you can kind of see how you can build a little bit more and more here. Any questions on initialize? Okay, just know that whenever you initialize a robot or initialize an object through a class, it'll call this function right here. Okay. And I kind of showed you guys, I put this in the thing, but you can also do something like you see how there's an initialize, but I can also do something called string. And this basically will be using, it's a built-in function. I'm just showing you an example of another built-in function. For example, if I try printing out Wally and Bender, you'll see that there's this weird like standard right here. And you're like, I don't know what this means. I can actually overwrite that. So then I'll give a string representation when I try to print it out. So basically it'll give the representation of robot name. So if I run this now, recreate Wally, recreate Bender in the same exact code, but this time try to print them out, you actually see instead of getting this weird junk right here, which is basically its memory space, I actually get something that's a little more readable, maybe more meaningful to my code. Okay. Again, this is just to show you that this thing can exist, and there's a bunch of these different functions, which I linked at the top of this subsection. Cool. And then inheritance, which we don't have very much time on this, but I do want to show you. Inheritance basically allows you to do more abstraction. So idea here is like we might have a robot, right, from this object, and notice that I pass in this object word right here to basically say, hey, this class of robot be an object. I do all that stuff we did before, kind of just following through. It's literally copied over. It's kind of showing you it again. So I run this part. But now after I define this robot here, this mold, I can make a more specific mold. Like for example, I can call it a garbage robot, and it's going to inherit all the properties from robot. And the way we can inherit these things is essentially do all the same stuff, but this time I can use something called super. And super basically says, all right, look at the mold for robot that garbage bot was made from, and use that initialize to do this part. So this is how you can basically create classes that very generic at first, very general, and then get more specific. So for example, I make a garbage robot here. but I also later make a bending robot here with different functions, but still inherits from robot. And I'll let you guys play around with that, but just to kind of show you guys what that looks like. I now made a bending robot that has these extra properties. For example, it has a bending ability when I initialize it. It also has a different function, bend it, but it also has some of the other functions. For example, it uses the initialize from the robot function. Okay, cool. Yeah, so I kind of went through that last part pretty quickly. So I would strongly suggest, go through this. Again, if you have any questions, you can always Slack out, that part. Definitely go through the curriculum because they have more and more examples that you can go at your own pace. This is all from section 7. But basically it's doing more advanced things with your classes. Okay, so any questions on this stuff before I stop the recording?